Okay, so besides this thing we mentioned before, we can recall in another file. So here we discussed about 4 of the primitive operations. The first one is called input X. So this input is a keyword. We have a parenthesis. Inside it, we have a variable, this X. So with this notation, we can read an element X from the database system to a memory buffer. So before this X is stored on the disk, so by use this operator, we can read this element from the disk to the memory. You can follow me, right? It's just a read some data from disk to the memory. And we also have the operation, it's called the readxt. What does this mean? This is to copy an element, this X. So X is in the memory buffer right now. We can copy this X to a temporary variable T. You can follow me, right? So this is assignment. We assign X to T, the value. Another operation we need to mention here is called write. Write means what? Write xt, we can copy the transaction local variable, this T value, to the element X. This is also the assignment. However, we assign this T value to X. You can follow me, right? This read is to read X and assign it to T. And this write denotes we assign the T value to X instead. And the last one is called output. Output X. This operation is to write this element X from memory buffer to the disk. I hope you can follow me, right? So the input is to read the X from disk to memory. Read xt is to assign the value in the memory buffer to the T variable. Write xt is to assign the T value from the variable to the X in the memory buffer as well. The next one is the output X. It outputs this X from memory buffer to the local disk instead. Okay, so these are the 4 primary operations of transaction we can write in a file. And with these 4 primary operations, we can execute most of the transactions in the database system. We can provide you with an example. Let's assume we have a transaction with several steps composed with these primary operations. The first operation we can use is to read a T. So we can assign this a value to a T variable, and then we can double its value by T equals to T times 2. We double the value, and then we can assign the value back to the A. Since A is the variable, we have the A copies in both disk as well as in the memory. And after this operation, we have read BT. It means we assign the B value to T, and we also double its value as well, and we can also assign its T value back to B. In other words, in this transaction, we plan to read the values for both A and B, and we also plan to double its value and write back the value as well. So the actions we have to take for this transaction cover several steps. So in this table, we can have both rows and columns. These rows denote actions. We have several actions for executing this transaction. And this column denotes the states of the transaction. It covers the value for both the local temporary variable T, as well as the memory buffer for A and B, as well as the disk values for A and B as well. So they together we define the internal state for the transaction. So you can see, right, the rows denote the actions, the columns denote the internal state for the transaction. As we do some actions, the internal state will change, right? So before we do any actions, we have a state for A and B on the disk. We have A, disk A equals to 8, its value. In other words, it's A entry, its value is 8. Disk B is also 8 as well. Before we do anything, so this state for T, memory A, and memory B, they are all empty or blank. We have no value for them. If we plan to execute this transaction, we have to read the value from the disk to the memory, right? Even though we didn't show them here. However, for the table, inside the table, we have this action or the operation for the input A. I always still remember this input A, right? This input A means we read data from the disk to the memory. For the A is a variable. Read the value from disk to the memory. In other words, we copy the value 8 to the memory A, right? For T and the memory B, they are still blank because we haven't used them yet. And then we can do this transaction. We read AT. Via this read AT, we can assign the A value to the T variable, right? Read AT, we assign 8 from memory A to T, right? The remaining they are still the same. We just do this assignment from memory A to T. Then we double its value. T equals to T times 2. In other words, we double this value inside its T variable, right? The remaining this entry they are still the same. We double its value, and then we can write a T. It means we can assign this T value to the A. This A means memory A, right? Because all the actions we are doing right now, they are based on the memory. We assign the T value from T to the memory A. In other words, we copy the 16 to the memory A. The remaining are still the same. And before we output this A value to the disk, we start the other step instead. We input B this value. It means we can read some data from the B disk to the B memory, right? Before the memory B, we have no value at all. And via this operation, we can copy or read this disk B, this 8 value to the memory B. And we can read BT, we assign its B value to T variable, right? 8, 8. Before this operation, this T value is 16. However, after this assignment, we copy this memory B to T instead. And then we can do this double of the T variable, right? It will become 16 because 8 times 2 will be 16. The remaining is still the same. And we can write BT. We copy this 16 to the memory B as well, right? After we do these actions, then we can write back both the memory A and memory B to the disk. So we can output A. It means we output this memory A, the 16 value, to the disk. It becomes 16, right? Then we can output B. It means we output this memory B, the 16, to the disk B, right? So via this action, we can do this transaction to double the value of both the disk A and the disk B. You see, all the action we have to read from disk to the memory and do the action based on memory, right? And then we can have to write back all the values back to the disk. Okay, so this is the example we can do for this transaction. We will use this example in the following pages as well for the crash recovery. And we will assume during the running time of this action or the transaction, we have some mistakes or some problems happens, we have to do the crash recovery for it. And we will discuss how to do this with this undo and redo as well.